is the cross-slot opener. It features a single disc, a wing-like steel bioblade on either side of the disc, and 2 packer wheels. As the disc slices through the soil, the bioblades briefly lift the earth, creating 2 horizontal fractured zones beneath the surface. The packer wheels, set at angles, fold the soil back in place over the opening. The seed drops in a space between the bioblade and the disc, about a centimeter out from the vertical slot. One of the advantages of the horizontal slot is that the seed can be inserted on one side, the fertilizer on the other. The offset between the two prevents seed burn. The depth of the 2 sides can even be offset to geometrically place the fertilizer in the optimum relationship to the seed. Each cross-slot opener is really a complete planting system with a number of unique features. Worldwide patents protect the bioblade technology. Each opener can stay in constant contact with the soil surface. The modular design will also allow the development of very large or very small drills, as well as the ability to infinitely vary the row spacings. There's even a patented memory valve that brings the opener back to the preset downward pressure after it has been lifted from the surface, as in turning. The United States Department of Agriculture received their first prototype of the new opener in 1986 at their research center at Washington State University in Pullman, Washington. In 2 years of research, the USDA has assessed the potential impact of this new technology on the agriculture of North America.
This research has involved a number of different research plots and broad acreage farmer fields where we have a variety of residues, soil types, and climatic situations. When seeding conservation tillage with the cross-slot technology, we find there are several advantages. The amount of residue left on the soil surface is significantly greater. Also, the seedling emergence, quality and quantity, are improved above the double disc opener. And most importantly, our most recent results have shown about a 15% increase in wheat yields. Another advantage of the cross-slot technology is the placement of the fertilizer in a perfect relationship with the seed row. This has several advantages, both from a conservation and from a crop production standpoint. It places the fertilizer below the soil surface so that surface runoff and erosion doesn't transport it to our streams. Secondly, it places it where the seedling can best absorb and utilize the fertilizer. Therefore, it's bound to be more efficient in terms of crop production.
The findings of researchers in carefully controlled test plots is one thing, but actual performance on the farm was also needed. A number of farms with various soil and climatic conditions were selected for field testing. Steve Hoffman has custom seeded over 10,000 acres with this early field prototype.
Well, there's always risk involved, and particularly in farming, and our ideas are to reduce the risk as much as possible, reduce all the risk as much as possible, because there's a few of the risks we can't control, the weather mainly, and the rainfall we get. You can do something about the way you place the seed in the ground, the way you conserve that moisture, by not tilling the ground, by not allowing the weeds to grow. You conserve the moisture and reduce that one risk, which is the major risk, I would say. We have quite a bit better seed emergence, and more sure seed emergence over a wider range of conditions.
The USDA is now planning to study the adaptability of cross-slot technology to other areas of the world.
The strong feature of the cross-slot technology is that it probably does the best job that I know of as far as conserving surface residues, which are very important for erosion control. And I can see where this technology could be adaptable to a very wide range of conditions across the world.
In the past, the greatest increases in yields have come from the favorable cropping conditions in the industrialized nations. Future increases will have to come from raising the productivity of third world farmers who use traditional methods to cultivate low-yield crops under marginal conditions. The cross-slot drill can be downsized to work with small tractors or pulled behind farm animals using existing fertilizers and seeds. This technology could help provide a new strategy of efficiency and sustainability that will meet the needs of subsistence farmers and begin to address the environmental and economic problems linked to more intensive cropping practices.
So it may be that we're about to come full circle. But can the introduction of a single new implement reverse the forces of a problem as massive as the rapid depletion of the world's soil resource? The answer might be yes. After all, it was the introduction of a single invention, the moldboard plow, that first set us on our current course. If there were an agriculture that had small economies of scale, which enriched the land rather than depleted it, that brought sustainability to the world's farmers, then such a system might well sweep across the globe from the Great Plains to the Third World, and with it turn back the advancing wastelands that threaten someday to starve us all. It may be that man will get a second chance to bring the land back from exhaustion, to build the soil up rather than to let it slip away, to take a harvest from the land and at the same time make an investment in the ability of future generations to do the same, to use the wonderful engine of life beneath our feet. That such a movement might take place seems almost inevitable. But the greater question may be whether the new technology will be adopted on a global scale in time to avert the coming crisis in food production.